Hello everyone. So today I'm going to cover two simple questions on sieve and SPF which we learned in the last video. Uh, Confirming these things earlier only, the sieve and SPF are basically the algorithms which you should know to optimize the questions, wherein you have to find the prime numbers, have to use the prime factors of a particular number. So most of the time I have seen this type of algorithms could be using with the help of with the with a combination with the DSU, disjoint set unit, a topic of graph, or with the Dijkstra, again a topic of graph, or with the DP, with the dynamic programming. Okay, so basically I have seen the sieve and SPF using merged with this algorithms to get a good type of question which you could see in the interviews or in your coding rounds. But I could find some basic questions which wherein we can write the code of sieve and SPF, wherein in the last video we have just run the algorithm for it, so we can have an hands-on on this type of questions. Okay, so this is a simple question again. The question says that you are given two positive integers left and right, and you have to find the two integers nums1 and nums2 such that nums1 is lesser than nums2, and those are between left and right, including both left and right. Both the num1 and num2 are prime numbers, should be prime numbers, and num2 minus num1 is the minimum amongst all other pairs satisfying the above condition. So let's say you will be given left as 10 and right as 6 as 20. Okay, then how many primes you have in between is 11, 13, 17, and 19. Okay, so the difference between 13 and 11 is 2, 17 and 13 is 4, and 19 and 17 is again 2. So what is the minimum difference? Minimum difference is 2, and which pair? It could be either 11, 13, or okay. They have said that we have to return this pair of nums1, nums2, and if there are multiple pairs satisfying this condition, return the one with the smallest num1 value. So other could be 17, 19, but your answer could be 11, 13 only, because you have to return the one with the smallest pair. Okay, and if you will be given nums1 left and right in such a way that you didn't find any prime numbers between these two, not any two prime numbers, then you will return -1, -1. Okay, okay. So basically, what are the steps which you can follow under this? Let let us have those steps which we can follow. Okay, so for the steps of this, first find sieve or write sieve, pre-compute sieve, which will find all prime numbers between, you can find it between L to R for optimized approach, or this is anyways pre-computing, so you can do for from 1 to n also, that will be still easier for you. And this will be a little bit optimized, because with the L and R range you can still classify and make the size as less as possible. But otherwise what you can do is L could be minimum 1, and this n is in this case is 10 raised to 6, so we can make a prime array of size 10 raised to 6 plus 1, and then we could find all the primes. Initially all are 1 except 0 and 1, because those are neither prime nor composite, so we could put prime of 0 and 1 as 0, and we can starting from 2 we can check. So what is the basically sieve algorithm for the, for just a brush up, we'll start from I is equal to 2 until I less than n, and I plus plus, what we will do, I square less than n. Okay, if we have prime of I as 1, that means if I is already prime, then we could go for j starting from I square till j less than n and j plus equal to I. Okay, and what we will make this prime of j as 0, because those could not be prime now anymore. Okay, so now we could know wherever the prime of I is 1, that means those are your prime numbers. So now second step, iterate from left to right, iterate from left to right, and if prime of I is 1, that means those are prime number. Okay, then take prime I and prime I minus 1. Okay, Again, you could have one minimum difference. So if prime of I minus I minus 1 is lesser than those minimum difference, update minimum difference and your answer pair. And one edge case here would be if primes, we will first collect all the primes. Okay, so before doing this, what we can do is at the middle step, collect all primes in one vector. Okay, all primes from 1 to n or from left to right, whatever you want, you can take left to right. Okay, and then if primes dot size is lesser than 2, that means you didn't have two primes also, you have either 0 prime or 1 prime, then you will return the pair minus 1 minus 1. That's what they have mentioned, right? Okay, so let's just not waste the time and just have a quick code on how to write the sieve algorithm. Okay, so let me share this. Okay, so while defining some constant, you could define it as static and then constant, those variables. So here you could see the size is 10 raised to 6. Okay. What you could do is you could also make an array of size this right plus 1, and then you can pass that array as a parameter while constructing your sieve function. That could also be one of the option, an optimized option, but I will still prefer this. So I could make a 10 raised to 6 plus 1 size of n. Okay, and I have my prime of size n. Okay, now I could have this void safe, and these are the global variables which could be accessible under my closest prime function also. Okay, what would I do is prime of 0 is equal to prime of 1 is equal to 0, and for 2 till n, what I'll do is I'll make prime of I as 1. Okay, now your main sieve algorithm starts. For int I is equal to 2, I square less than n and I plus plus. If prime of I is equal to 1, then I'll start with I square. I'll go until n. Every time I'll take the multiple of I. So j plus equal to I, and I'll make this j as false because this is not a prime now. Okay, we are done. So we'll call just the sieve algorithm, and I'll store this prime numbers in one of the vector starting from left until right equal to right. Okay, because we have to consider equal to also. So from left to right, if my prime I is 1, so if prime I, then prime numbers dot push back this I, right? I'll push back this I. And now what I have to do is, again, I have to take this minimum difference. So let's take this as int max as of now. And we could have one closest pair also. So let's have a closest pair which is initially minus 1 minus 1. So if my prime number's size is lesser than 2, I will return this closest pair as it is. Minus 1, which is. Okay. Now, you can start from 1 till prime numbers size. The difference is, again, prime numbers of I minus prime numbers of I minus 1. If this difference is lesser than minimum, then only we'll update. Otherwise, we have to return the smallest pair with num1 value, right? So if this difference is lesser than minimum, I'll make this minimum as difference and my closest pair as prime numbers of I minus 1 and prime numbers of I. Cool. And after doing this, we'll return this closest pair. Okay, let's see. So this is a simple use case of sieve algorithm. I know it's not a bigger use case, but as I've said, the main use case you could see while doing the DSU related questions, disjoint set union, or while doing the Dijkstra related questions, or under the DP related questions. Okay. Okay. Let's see another question which is related to SPF. So the question says that given an array of positive integer nums, we have to return the number of distinct prime factors in the product of the element of the nums. Okay, let's just understand it a little bit and then we will switch to this question itself. Okay, so the question says that you are given in positive integer nums and we have to return the number of distinct prime factors in the product of the elements of the nums. Note that a number greater than 1 is called prime if it is divisible by 1 in itself. An integer val1 is a factor of another integer val2 if val2 is divided by val1 is an integer. So this is the definition of the prime number which is given to you. And the example is this one. Okay, so now you could know with the help of SPF, while after calculating the SPF, by dividing the num by SPF every time until we get 1, we will get the all prime factors of the particular number. But we could get multiple, like for 2 we'll get 2, for 4 we will get 2 into 2, for 3 we will get just 3, for 7 we will get just 7, for 10 we will get 2 into 5, and for 6 we will get 2 into 3. Okay, so these are all things. But now we have to store this. The only thing we need to consider is, let's write the steps for this also. Okay. So what we will do is, with the help of sieve, uh, okay, with the help of sieve, calculate SPF of each number, which is the smallest prime factor of each number. Okay. And now uh, take all prime factors of each number in array, because anyways for the product also you have to multiply this all numbers. So 2 into 4 into 3 into 7 into 10 into 6, whatever number this have, it has 2 to the power 1 2 3 4 5, 2 raised to 5 into 3 to power 2 into 5 into 7. This is what the prime factorization of this particular, the product of this whole number. So that's what it said. After doing the product of all the elements, we have to return the distinct prime factors. To get the distinct prime factors, we will store it in the set. That's the easy way we can do. So take all prime factors of each number in array and store it in a set. So your answer will be set dot size. Okay, fine. So let's just solve it now. Okay, so again we have a how many maximum numbers we could have here is, nums dot length could be 10 raised to 4, but nums of I value could be 1000 only, right? It could be 1000 only. So we need to make it until 1000 only. So we'll have a prime or not. We'll have a SPF vector itself here of 1001 I could make, correct? We could have an SPF error directly. Now no need of storing it as prime or something like that. Okay, we'll have one sieve. This sieve will store the prime instead of storing the prime number. Instead of storing whether the number is prime or not, it will store SPF, smallest prime factor. Okay, SPF of 0 is 0 and SPF of 1 is 1. Okay, initially we store the SPF of each of value as I only. So I'll better to take it as n only. So static constant n is 1001. Okay, so for int I 0, I less than n, I plus plus, SPF of I is equal to I. So initially I've put smallest prime factor as the number itself. Okay, now for int I is equal to 2, again the same sieve algorithm you have to use. Now what you have to do, if SPF of I is equal to I. That means this is the prime number. If SPF of I is again I, this is prime number. I is prime number. Okay. And then I'll go into all its multiples starting from I square until it's less than n multiple of all this i's. Again, now there, while writing the sieve code, we do prime of j as false only directly. But here we need to check if SPF of j is equal to j, then only I'll make SPF of j as I, because I have given you example in the previous video. Let's say for 3, you'll start from 9. So 9 and then 9 plus equal to 3 is 12. But for 12, the smallest prime factor is 2, which we have already replaced with when we had I as 2. So we won't replace with 3 again, because 3 couldn't be the smallest prime factor for 12, right? 2 is the smallest prime factor. So we'll do SPF of j as I over here. Okay. And we are done with the SPF. Okay. And we are done with the SPF. Okay. So we'll first call the sieve algorithm, and we have this as nums.size. Now we could make a set above only saying this set is answer. Okay. And this could be unordered set, right? Because we want a global. And every time I'll store void prime factors of for each number num. So while num is not equal to 1, what I'll do is, while num is not equal to 1, or while num is greater than 1, okay, because num would be positive only, what I will do, uh, I will push back the SPF of num under my answer, and I'll divide this num by its SPF. Right, that's what we have seen to get all the prime factors yesterday. I'll divide this num by its SPF every time. Okay, so what we can do is, for each of this, for int I0, I less than n I plus plus, I will call this prime factors method now by passing each of these values under this, and I will return this answers size. I hope you got my point very clearly. So what we have done initially, we have pre-computed the sieve. Okay. Oh, it's not pushback, it's insert under the set. Okay, so we have initially pre-computed the SPF of all the numbers, and then for each number in the array we find all the prime factors, but that could be multiple duplicates. Okay, and we need only the distinct, so we store it in the set and we just return the size of the set. I hope it's clear. So with this we are completing the important concept of maths, which include modulo arithmetics, with the main part as modulo inverse, and then the sieve algorithm and SPF algorithm, considering the two main topics which could be used when we solve the problems related to DSU, DP, and all those stuffs. Okay. Now, just comment me down what you want as the next topic. It could be either graph or DP. I don't want to waste time on the short topics now. Whatever is important for your coding rounds, I think we have covered a lot of those. Okay, small ones. Now we could jump directly to the graphs or the DPs. Whatever you want, please comment me down as soon as you can. Stay tuned for the next series of next playlist with the another new topic. Stay tuned, stay safe. Do like, share, and subscribe. Bye bye.